things just to know it. That is also well said. Guys, always remember in a textbooks or in a material, so many things, different kind of stuff will give. But really, in our regular network, either it is home network, office network, in our regular network, what we use to communicate for addressing purpose, logical addressing, logical topologies purpose, use IP address only. Mainly IPv4 only we are using. IPv6 in a certain organizations, certain internet service providers giving this IPv6. But generally we are using IPv4. Commonly, we are using IPv4. Some places, some organizations, some service providers use IPv6. Like Geo use IPv6 also. And the different protocol suites are there. Out of all, we are all globally using TCP/IP protocol suite to communicate in the network. So different layers of communication is there, like a physical layer, application layer, network layer, like that's a different layers of one kind of network. Like I open an application, I need an IP address, I need a transmission protocols, right? So different type of encryptions we use. Okay, so different protocol models are there to communicate in the network, but globally we are using TCP/IP protocol suite only. Okay. Next, the cabling type. So of course there is different type of cables. Are there coaxial cable, twisted pair cable, UTP, STP cables, fiber optical cables. Okay. So different type of cabling we are using, but commonly we are using UTP type. Means in twisted pair we are using unshielded twisted pair UTP type only. We have learned about the different physical topologies, bus ring, mesh topology kind of stuff. So we use always star topology. So most commonly used, maybe in some special cases, certain cases, it may different, but most commonly we use IP addresses, that too IPv4 and TCP/IP protocol suite only we are using to communicate in the network. The cable, if you are using a cable, not wireless we are using, of course, but if you are using a cable, that is UTP cables only we are using. Star topologies, the way you connect devices in star topology. That is the first point. So always keeping those things in mind. IP addresses and MAC addresses. What is this? IP address is a logical address, MAC address is physical address. IP address is uniquely identify a device in the network. MAC address is physical address or hardware address, and it is unique address. IP address can be changeable because either we assign manually or automatically it is assigned by DHCP server. That MAC address is assigned to the NIC by the manufacturer of that NIC. IP address, I think last class only we discussed this one, but just better we have go through once again. In IP addresses, currently IPv4, IPv6 versions are there. So IPv4 is 32-bit, IPv6 is 128-bit. In MAC addresses, we do not have any separate versions. Only one version only we are using. So MAC address is with the 32-bit and represented in hexadecimal format. 12 hexa numbers are there. So this is MAC address and IP address differences. Again, and guys up to here, okay?
Yes, sir.
Okay, 32-bit, 128-bit. So what is this? IPv4 is 32-bit, IPv6 is 128-bit. It means you take an IPv4, so the total, if you write in a binary, it is 32-bit. So for example, I am writing okay. something, put a yes, it is totally 32-bit. Okay, it is totally 32-bit. So you can count each 1010 kind of stuff is 1, 2, 3, 4, 5 like this. It is totally 32-bit. Okay, so if you are say like it is starts like from zeros 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, so I will try. No, so 8, 8, 8, 8, totally 32. This is the starting number. In IPv4, this is the starting one. All zeros. And ending will comes like this. All 32 bits are ones only ending. Okay. So how to calculate? It's a 2 to the power of 32. 2 to the power of 32. 32 bit means 2 to the power of 32. It is 4.3 billion. Billion. Okay. 4.3 billion IP addresses. Start from here, end from here. And it is from here to here, totally 4.3 billion IP addresses. So if you write in a normal manner, almost you can say 4 billion 294 millions 967 thousands to 96. This is in billion million manner. Otherwise, you can write like this: 42 crores. No. This is one, right? 429 crores, 49 lakhs, 67,296. This is actual number of IPv4 IP addresses. So total number of IP addresses, start to end of the IP addresses. It is represented in decimal format. So I've written in the binary format, but actually we write in the decimal format. This is an example for an IPv4. And coming to the IPv6, it's 128-bit. Similarly, like this is, you can see zeros and ones. If you write 128 bits, zeros and ones in the IPv6. Okay. 2 to the power of 128 is 4.3 billions of IP addresses. It is exactly say 3.4 into 10 to the power of 38 or 34 into 10 to the power of 37. Those many number of IP addresses you are getting. So because IPv4 almost all the decade time is done, so it is not enough for entire global communication nowadays. Okay, we are still managing, but IPv6 is going to replace everything because huge number of IP addresses we are getting. And it is in decimal format. You can see this is the way you can write a IPv6. Okay. I said this is IPv4. This IPv4 is just, I am just trying to show you, divided into 4 parts. IPv4 is divided into 4 parts. So total it is 32-bit and you will divide 32 by 4, each part having 8 bit. It means this is 8 bit, this is 8 bit, this is 8 bit, this is 8 bit. Each part is 8 bit. And each part is separated by a dot. What we call this, not point, dot. Okay, dot. And I said each part 8 bit. How many? 4. Totally 4 8 bits are there. Okay, this 8 bit we call it as a octet. Octet. This is called octet. This is one octet. This is second octet, third octet, fourth octet. So totally 4 octets. We have a 4 octets. So this is called a first octet, second octet, third octet, fourth octet. Okay. So totally 4 octets. Each octet is 8 bit in size. One again, what is octet? 8 bit. 2 to the power of 8 is 256. 2 to the power of 8 is called a 256. So in each octet, the maximum size is 0 to, this is 0 and this is 255. Means one octet, each octet, the range is 255. So every octet is minimum 0, maximum 255. Okay. So no octet contains more than 255. No octet contains more than 255. If I write some IP address, 100 dot, 200 dot, 300 dot, 40. It is invalid IP address. Why? Between 255, 0 to 255, 0 to 255, 0 to 250. Good. But this is outside of 255. More than 255, it is invalid. Either it is in middle or above. For example, you write this is for example 400.200.2.4. Again, it is invalid. Why? More than 255. You put a 1.1.2.1. Good, valid because it's between 0 to 255. Okay, guys, understand each octet is between 0 to 255. Same thing I have written here. IPv4 divided into 4 parts. Each part is 8 bit called octet. Each octet is separated by dot. Octet means 8 bit, 2 to the power of 8, 256 means 0 to 255. The first octet we call it as the first octet, second one is second octet, third is third octet, fourth one is fourth octet. Some people, for the more convenient purpose, they're labeling with a different kind of system. They will follow different kind of system like ABCD, but ABCD classes are there. So to avoid the confusion between class and following some system, so they use this kind of stuff. Like the first octet as W, second octet as X, Y, and Z. This is for some people, some books, for the easy, convenient purpose, they use it. But standard is always first octet, second octet, third octet, and fourth octet. Okay. So why I'm telling this is even I don't use WXYZ, but if you hear something in some YouTube or someone, they try to say in WXYZ. Okay. So you should not confuse. Why they use this one, SAR said one first octet, second octet, but they are using this one. Someone, in both cases, someone is wrong. But I'm not trying to say that it is like that. Okay, so don't. Again, I think I have to rewrite. This is different and this is different. We copied in different ways. Okay. The first octet range is 0 to 255. Second octet range is 0 to 255. Third octet is also 255. Fourth octet. Yes, the first IP address, very first IP address is 0 dot 0 dot 0 dot 0. This is the first IP address. The next IP address is 0 dot 0 dot 0 dot 1. This is not binary numbers. These are decimal numbers only. These are decimal numbers because we don't write in a binary format. So in a system or ourselves. Okay. So anyway, for our understanding, for certain calculations, we have to convert into binary. Okay. You have to convert into binary. You have to convert into binary. See it is always go like this one. Here I am trying to say 254. Okay, if you see the sequence 0 dot 0 dot 0 dot 254. The next one is 0 dot 0 dot 0 dot 255. I said 255 is the last one. So what will happen? See, it is 0, 9. 9 is the last number in a single decimal number, right? So what will be the next? 1 0, 1 1, 1 9, then 2 9. So 2 0, 2 1, 2 2, finally 2 9, then it is 3 0. 99. After that one, 100. So you're automatically 0. Similarly, it is the same numbering system on 1.0. So what happened to 0.255? It become 1.0. Again 1.1, 1.2, 1.255, 2.0. It goes on like a 2.1. Again, once it is you reach 255.255, what happened? 0.0.0. So 1.0. Like it is always go on. And finally it reaches 255 dot 255 dot 255. Okay. So I think this is in this line. Something we missed that line. Okay, I will cut this one. I put it here. Okay. See, it is 0. This is starting one. This is ending one. Total IP address ranges from 0.0.0.0 to 255.255.255. So no octet is more than 255. So total any IP address, it should be between this and this. It may be like this, it may be like this, it may be like this, but IP address range is in between these two things. Okay, guys, up to here understand what is IPv4 and 132-bit, how IPv4 is look like, what is first octet, second octet, third octet, and fourth octet, and the ranges. each one, every point is important. So I cannot say this is important, this is not important. I have written only important points. Just up to here, okay? The IPv4 ranges.
Yes, sir.
Very good. Okay. IP address range divided into 5 classes. This is total range. This is a total range. But this total range is divided into 5 classes. So I have written this 0 dot 0 dot 0 dot 0, and the finally the last one is 255, 255, 255, 255. So in between, below one are there. So like this, 2 is there. Okay. Maybe a 2 dot 0 dot 4 dot 5. Okay. So many are there. So like 120 dot 0 dot 2 4 dot 5. Like a different number from 0 dot 0 dot 0 dot 2, the 255 dot 255 dot 255. This entire one we divide into 5 classes. This entire range we divide into 5 classes. So class A, class B, class C, class D, class E. Totally 5 classes. This entire range. Class A range. Okay. The class A range is from 0 to 127. Okay. 0 to 127. So if I write an IP address, so for example, same thing. If this is 120 is there, no? 120. Check the first octet. See the first octet of IP address. If that first octet is range is between this class A, that is class A IP address. This is class A IP address. 0 to 127. If you check in certain textbooks, it shows 1 to 127 or 0 to 126 or 1 to 126. Of course, this is the correct answer, guys, 0 to 127, but this is also correct answer. How? Because there is certain reasons are there. That I will tell. Anyway, next class B range is 128, 191. For example, 150.60.2.4. This is 150, right? 150 is in between this range. So it is class B IP address. So what we have to check, that always check the first octet. Class C 192.160, sorry, 192 to 223. 192 to 223. Okay. So you write 195 dot 120 dot 150 dot 2. Which class it is? Class C. Because whatever the next octets, we don't mind. We are always check the first octet only. So if first octet, which range? Class A range, Class B range, Class C range. Based on that, we will decide. Class D is 224 to 239. Class E 240 to 255. Okay. So these are the different classes. For example, you write an IP address like 224 0.0.5. It is a class D range. Once again, check it here. IP addresses, the total IP address range is divided into 5 classes. To check which class of this IP address, we are always put it under first octet or a W portion of a IP address. Check the first octet and compare that octet range with our class ranges, and we can say which class of IP address. Class A 0 to 127 or 1 to 126. Class B 128 to 191. Class C 192 to 223. Class D 224 to 239. Class E 240 to 255. Okay. So compulsory remember IP address, class and range. Okay. Guys, here it is. Few points you have to remember again. These first 3 classes, class A, class B, and class C are unique cast IP address. Unique cast IP address. Class D is multicast. Multicast. Class E is R&D. What is this? Unique cast. What is unique cast? I have a device and I have a device and I have a device and I have a device. For example, this is 1.1.1.1. This is 1.1.1.2, 1.1.3, 1.1.1.4. For example, these are the IP address of A, B, C, B, C, D. APC, BPC, CPC, DPC. Okay. For example, A want to communicate it to B. A ping B. Ping 1.1.1.2. So request go to which system, guys? To A, B, C, D, or only B based on this request from A to B. Okay. So I given only B's IP address. So request go to the B's IP address only. Okay. So this is called a unicast. One-to-one communication. We are all in this meeting, right? So for example, I am asking a question, Bhargavi, what is the IP address of CPC? So to whom am I asking? Only one person, Bhargavi. So I'm specifying a specific person or specific system and asking a question or sending a request. So one-to-one communication. So this is called a unicast communication. What is multicast communications? Multicast communication is like a group call type. Okay, group messaging type, group discussion type. It means everybody having a same address. For example, this is having a 224.0.0.10, for example. It is not assigned to any. You cannot assign IP address like this. It is depends upon some protocol and some programming, but all these are having a same IP address. For example, here is some system. This also should have a same kind of IP address because they want to communicate. It is sending a packet with the same IP. This IP only. That same packet is sent to this, and this, and this. So which IP it is sending? This. Who is having all this? So this is multicasting. For example, I ask a question. Do you understand what is an IP address? Do you understand what is the, do you understand IP address ranges? To who I'm asking? I'm asking all of you. I'm not specifying any one single person here because all of people are in the same group. So we are batch 3. I told to Raman sir, the batch 3 today class is completed. So can you able to take the class? Or maybe ask, I told Raman sir, the batch 3 classes performance attendance is good. I'm not talking about one single person. I'm talking about the whole group. So everybody having a common address here. So that is a multicasting. What is broadcasting? Broadcasting is to everyone, irrespective of a specific group or entity. Okay. So guys, we are not using certain range of IP addresses and we are not assigning. We are not using, it's the wrong answer. Actually, we are not assigning certain type of IP addresses to the systems, to mobile phone, laptops or desktops. We don't use this set of IP addresses. One is multicast range IP address, means class D range, we don't use it. Another one is class E range, also we don't use it. So which range we are using? From class A, class B, class C ranges only we are using. Out of that one also, we don't use it. For example, this 0 dot, 0 dot, 0 dot, 0. This is also, we don't assign. Instead of telling not using, we don't assign to any mobile phone, laptops or desktops. Why we don't assign this particular IP address? It used for a different protocols. For example, DHCP type of protocol use that one. Default routing use that one. Okay. In some places, yellow all, deny all kind of ACLs, like a access control list, in that one also use this kind of IP address to represent yellow all or deny all kind of stuff. Okay. All or no kind of stuff. Okay. We do not use this thing. And also entire range, entire 0 range, 0 dot, 1 dot something, that those things also we do not use. So we are not using entire 0 series. Next one is 127.0.0.1. This is called a loopback address. Loopback or localhost address. What is this loopback or localhost address? For example, I need how many things I've opened? This is good. Again, let's look at here. I have a systems. Listen very carefully, guys. I'm telling. I didn't ask anybody. Do you understand or not? In this PC, for example, in this PC, I installed an application called MySQL. It's a database application, right? Just for example, I want to access from a PC. I want to access this from my PC. So MySQL client. So I'm using some client, a MySQL client application. From the client, I'm accessing the server. Where is the server? In APC. Where is the client? In APC. I want to send a request, connecting request with a local host request because both are in the same place. So I ask local host or IP address 127.0.0.1. Okay, localhost or my SQL client, or you take things. Okay, for example, guys, this is APC having an IP address. For example, IP address is 10.10.11. This is BPC having an IP address 10.10.12. CPC having a 10.0.0.13. For example. So where is my server? My server is at A. From my server means from A, I want to connect. I use localhost name or I use localhost IP address called 127.0.0.1. For example, from BPC, I want to connect. From here, I have a client. Here is my SQL client application. I want to make a connection, means I want to send a request to connect this database. Okay, how to put a request? 10.0.0.11 only, because 10.0.0.11 is belongs to A. Then request go to A and this particular service with a protocol port number, not local. Okay, guys, every system itself local host. What are the name of the system? Okay, every system there itself is a local host. Okay, but so only we use itself type. I'm keep telling, but no one is getting doubt or anything. Usually it is difficult to understand. Again, guys, we cannot assign or configure IP address to the devices. You have a computer, a laptop, or a desktop, mobile phone. You don't assign certain IP addresses. One is this IP address 0.0.0 as well as entire 0 series. So this 0.0.0 is a reserved IP address used by certain protocols like DHCP or default routing concepts. 127.0.0.1 is also a reserved IP address. So we cannot assign this particular IP address to any of the devices. It is used as a loopback or local host. Self-testing purpose, loopback, self-testing. So I'm going to test myself. I'm pinging to 127.0.0.1 to test, to make sure that my TCP IP application is running or not. My TCP IP service is running or not. So I'm testing myself. I'm not pinging to any other system. I'm pinging to myself only. It is exactly say localhost loopback or loopback ID is 127.0.0.1 is like a myself self. Remember that IP address, remember the concept. Self-testing, self-accessing type. And of course, entire 127 series is you are not assigning. Okay. And also you cannot assign an IP address of class E because it is R&D, research and development wing part. So still maybe in some special cases, people may use this class E, but generally general public We don't use class E. Next one is class D, multicast IP address. So these multicast IP address, you cannot assign to individual systems. It is managed by certain protocols like RIP version 2, OSPF, BGP, BootP, okay, network-wise deployment kind of stuff. Class A, Class B, Class C are unicast addresses which are assigned to our device. Of course, from Class A, yeah, tell me.
Yeah, so that means class A, B, and C addresses can be changed by yourself.
That we can able to assign Class A, Class B, Class C. Even though Class A, the 0 series 127, we don't use it. That's why I put a one bracket 1 to 126 because we don't use 0, we don't use 127. So this is using part. This is total range, but usage part is this one. Okay. 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 Identify which class of this IP addresses. Okay. So when you see an IP address, which class of it? That is very important, right? So I remove these classes, try to figure it out. Always see first octet, 137. Class A, 0 to 127. Class B, 128 to, what is the next one? 128 to?
191.
Very good. 192 to 23. Okay. 224 to
232.
239. Good. Class C, 240, 255. Okay. So now 134. Which range? So which class it is? Is class B. 156. Which class?
Class B.
Very good. 10.
Class A.
Very good. Is class A. 194.
Class C.
Class C. Very good. 227.
Class D.
Class D.
Class D. Very good. Okay. This is how you can recognize which class of IP address it is. So when you see an IP address, what we have to see? First octet and recognize based on the first octet which class of it is. Okay. If you practice, you will. It is very easy thing. Okay. So this is IPv4 again. Once again, IPv4 32-bit 2 to the power of 32 3.4 billion IP addresses. It is written in a decimal format. So it is look like a this IP address 192.168.1.34. This total 32-bit is divided into 4 parts. Each part is 8-bit called a octet. Each octet is divided by 4, divided by sorry, 4 octets and separated by dot. Okay. So first octet called first octet, second octet, third octet, and fourth octet. The IP address starts from 0.0.0 and with the 255.255.255. This entire range, the entire IP address range, if you write from 0.0.0 to 255.255.255, so if you count it, the total number of IP addresses are these many. The meaning is that one. Okay. Next one is entire this range is divided into 5 classes. There is a reason to divide 5 classes because of different type of networks need a different number of hosts in the network. So that also we will discuss, but up to now here. So you have an IP address and how to recognize which class of it. The classes are divided based on the first octet of IP address. Okay, the class A, the first octet range is 0 to 127, and the 0 series and the total 0.0.0 is we cannot assign to any system. 127.0.0.1 is local host or loopback address used for self-testing, same system access purpose we are using it. And 127 series also we are not using. So these two are we are not using. That's why people write in a certain textbook, some websites 1 to 126. The total range is 0 to 127, and we don't use 0 and 127. Class B 198, sorry 128 to 191. Class C 192 to 223. Class D 224 to 239. Class E 240 to 255. Class E is a research purpose. Still, okay. So Class E is reserved kind of stuff, research purpose, reserved kind of stuff. Maybe some special cases they use it. Okay. Class D is for multicasting purpose. It is used by certain protocols and certain services purpose only. Class A, Class B, Class C are unicast addresses. Out of that one, 0 series, 127 series, and one more series is there. So accept those, all remaining used in the communication. Of course, we can able to assign to the devices. We can't assign 0.0.0 or 0 series, 127 series. Also, we can't assign. How to recognize which class of IP address it is? See the first octet and you can able to recognize first IP address. So this is up to here. Guys, take a 10 minutes of break. So then I will explain this network portion and host portion. So today we'll see this network and host subnet mask. Okay. Private and network. This part we will complete today because it is a major part, a big part. So Monday we'll discuss OS layer. Okay. Take a break. I'll come back at 12:05, 15 minutes.